Hi everyone. So now let's take a look at our third case where you have the denominator in which there is a quadratic polynomial that cannot be factorized. For example, in this case. So we have a linear polynomial 2 plus x and we have a quadratic polynomial also 4 plus x squared which cannot be factorized unlike the case 3. So how do we decompose this kind of fractions? As I said earlier, whatever is the degree of the denominator, the degree of the numerator in the partial fraction is going to be 1 less. So we have a linear polynomial. Its denominator will be just a constant a over 2 plus x. And now we have another one which is a quadratic and that cannot be factorized. So the numerator for this is going to be 1 degree less, which means it will be linear. So a linear polynomial can be written as bx plus c. We have to use a different use a bx plus c. So this is quadratic, has a degree 2, and this is linear, 1 degree less, so has a degree 1. Okay. And now the next few processes are the same. We have to find a, b, and c by the process of elimination, sometimes also substitution. So let's see how we can do this. So we have x multiplied with 6 minus x over 2 plus x and 4 plus x squared is equal to a over 2 plus x plus bx plus c over 4 plus x squared, and multiply both sides of this with this whole denominator 2 plus x and 4 plus x squared. So now if I do that, in the left hand side we are left with x multiplied with 6 minus x. In the right hand side we have a. This 2 plus x will cancel out with this 2 plus x, so we will have 4 plus x squared plus bx plus c. Now this 4 plus x squared will cancel out with this 4 plus x squared, so we'll be left with 2 plus x. Now let's find a, b, and c by using elimination. What can I put as x? What can I substitute x as so that b is eliminated? Okay. So b is together with x. The only way to eliminate b is to make x as 0. So let's substitute x is equal to 0 on both the sides. If I put x as 0, then this becomes 0. I think x equal to 0 will not work over here. So that's because I'll also have c there. So let's first try to eliminate b and c to get a. Okay. So if I want to eliminate b and c, that means I need to get rid of this. Let's substitute x as negative 2. X is equal to negative 2 will give me negative 2 multiplied with 6 minus 2, which will be 8, is equal to a times 4 plus negative 2 squared plus b times negative 2 plus c and 2 minus 2. So this whole thing will become 0. B and c is eliminated. So we can find a. Negative 2 multiplied with 6 plus 2 is 8 is equal to minus 2 square is 4. So 4 plus 4 is 8 also. 8a. That means a is equal to negative 2 multiplied with 8 divided by 8, and that is equal to negative 2. So now we have the value of a, which is negative 2. In the next step, we'll try to eliminate b so that we can find c. And we already have the value of a. So again, we take this x multiplied with 6 minus x is equal to a, and a now is -2. So a is a times 4 plus x squared plus bx plus c multiplied with, say, 2 plus x let's now put x is equal to 0. Why we are putting x equal to 0? So I can eliminate b. So 0 multiplied with 6 minus 0, this whole thing will become 0, is equal to a. Now we have the value of a, which I can put here. -2. The first time when I was trying, we didn't have the value of a. So -2 and 4 plus 0 plus 0 plus c and 2 plus 0, which is 2 also. So 0 is equal to -8 plus 2c, which gives us 8 is equal to 2c, and so c is equal to 4. Now we have the value of c also. So we have the value of a, we have the value of c. Now we need to find the value of b. So in order to find the value of b, this time we are not going to eliminate, but we are just going to substitute x as one of the simplest values, whatever value you can think of, a simple value to find b. So the simplest number, which I think is 1, because putting x as 1 makes the calculation much simpler. So if I put x is equal to 1, let's just take the same equation first. X times 6 minus x is equal to a multiplied with 4 minus x, 4 plus x squared plus bx plus c. This is what we got. This is what we got from our this step, right? This is a very important equation. So in here, let's put x is equal to 1. You can take any value of x. Why I'm taking 1 is because I find putting 1 in the equation keeps the whole equation very simple and easy to deal with. You may put -1, you can put 2, you can put any value as long as b doesn't get eliminated, because we want to find the value of b. So 1 multiplied with 6 minus 1 is equal to a, and we found the value of a as -2 times 4 plus 1 square is 1. You see, that's the reason why I took 1. If I had taken anything other than 1 or -1, if I taken 2 or 3, then 3 square becomes 9, 2 square becomes 4. This whole number becomes much big, which we don't want, to keep our calculation simple. B is 1, sorry, x is 1, so b times 1 is 1, plus c, which is 4, and 2 plus 1. 6 minus 1 is 5, is equal to 5 multiplied with -2, which is -10, plus b plus 4 times 3. So 5 minus 10, 5 plus 10 will become 15, is equal to 3 times b plus 4. That gives us b plus 4 is equal to 15 divided by 3, which is 5. And from here, we get b is equal to 5 minus 4, which is 1. So we got the value of b, we got the value of c, and we got the value of a. We can now finally write the entire fraction as, just give values to a, b, and c. So a is, a we found as -2. So we can write a as -2. B is 1 and c is equal to 4. So we can put the value of b and c as 1 and 4. So we have 1x plus 4, and we actually don't need to write 1, so we can just get rid of the 1. Just write it as x plus 4. That's our answer. So x times 6 minus x over 2 plus x, 4 plus x squared. can be written in terms of partial fraction as -2 over 2 plus x plus 4 over 4 plus x squared. That's our final answer. That's it.